VLSos here. This is a video lesson on U substitution. Let's start with an example problem. We have a complicated problem, m squared plus 5m minus 24 all squared minus m squared plus 5m minus 24 is equal to 6. I have three terms being squared, and then I'm subtracting more terms, and it's an equation. I could square this. I could proceed by squaring, combining like terms. It would be a little bit challenging to keep track of. But there's a strategy if we notice that what's being squared and then what we're going to subtract is the same group of terms. This piece in parentheses is identical to this. Then we could choose to simplify the problem by assigning some complicated mathematical expression a very simple expression u, and converting it into an equivalent equation that looks easier to deal with. In this case, if I assign the letter u to be the expression m squared plus 5m minus 24, which I see repeated here, then each of these pieces can be replaced with the u to make this u squared minus u is equal to 6. After I've done that substitution, I can focus on solving for u. This quadratic equation is fairly easy to deal with. If I subtract 6 from both sides, I could use the quadratic formula, or I could notice that we've got a factoring pattern and make a good guess and check that the factored form of this quadratic is u minus 3 times u plus 2 is equal to 0. And I could get my u values, 3 and 2, negative 2. But I'm not finished. My original problem was an equation with the variable m. And I replaced all of the m's with u and just found solutions for u. But I'm not finished until I resubstitute or substitute back what u is equal to in terms of m and continue to solve for m. That means that I found values of u, but u is equal to this expression. So the values that I found are also equal to that expression. I'm reintroducing the piece that I temporarily took out. And if this case, this expression, which is quadratic, is equal to two different values, then this is equivalent to trying to find solutions to m squared plus 5m minus 24 when it's equal to 3, and m squared plus 5m minus 24 is equal to negative 2. Continuing with this solution process would require me to find values for m, and in this case I have two quadratic equations to find m, and I would expect that 4 values in the end could be found for m. The purpose of this was to introduce how to substitute in an expression, u for an expression, to get to a place that is easier to calculate the solutions afterwards. Let's try this again with another example. I have the equation 4x squared plus 4x minus 3 all squared is equal to x squared minus 5x minus 6 all squared. Fairly complicated. I could square both sides. It would make quite a pile of terms. I could combine terms, and I could proceed from there. Let's consider U substitution. I'm looking for a complicated piece to simplify by assigning U to temporarily be equal to it. In this case, if I choose U to be 4x squared minus 4x minus 3, then I could substitute this with U, in which case I would get U squared is equal to not the same expression. Can't substitute U for this because U is assigned to be something different. But if I continue, then I get U squared is equal to x squared minus 5x minus 6 all squared after a U substitution. But did it help? No. Notice what I came up with. I have an expression now with two variables, U and x. And it's not going to help me to solve this for U because I wouldn't get values. My attempt at U substitution did not help, and it wouldn't help to assign U to be anything different. U substitution is helpful only under certain circumstances. U substitution is helpful when you have a problem when there is a repeated complicated piece. In my original example, there was a repeated complicated piece. So assigning U to be equal to it temporarily helped me in the solution process. In the second example, there are complicated pieces, but not repeated. So assigning U to be equal to one of them doesn't help.